Hey guys, it's Mr. Ripes here. Sorry I couldn't make it to class today, but I will definitely be there Thursday. Basically what you're going to do is listen to this video. Hopefully you have your headphones in. If not, get them out now, put them in. We're going to go through the rest of the notes, and you're going to follow along. I'm going to tell you at certain points in the video to pause it and go back to Notability for these notes and complete a few more problems. And then once you complete all the notes, and you will have to complete them at the end of class today, you're going to turn them into Canvas. You will submit them into Canvas, and I will look over them at the end of the day. Okay? So, not only are you taking notes, this is also an assignment, an in-class assignment that you will turn in at the end of class, because I would like to see the good work that you have done when I am not there. Alright, well, we're looking through still this factors and prime factorization stuff, which we did start, and you might remember we made a list from the of the prime numbers from 2 to 60. We circled the primes, we X'd out the composites, and if you need to, look right in front of you. There's a list of the first 100 prime numbers right there in the classroom, so we can use that as reference as well. Now, page, we also talked about a brief moment in history about prime numbers. That was also very interesting. Hopefully you had a chance to read over that. If not, please do that now. So here we go. We didn't talk about this. Where have you heard the word prime before? Just in the normal English language. For example, if we look on the notes here we have Optimus Prime. Exactly, his name had the word prime in it. But there's also Prime Minister. And what else? Take a moment right now to write 2 more phrases or words that have the word prime in it. Pause the video now and do that. Okay, you should have written 2 more phrases that have the word prime in it. Look at those words, like Optimus Prime or Prime Minister or whatever else you wrote. Do you notice that the word prime indicates something very, very important? That's exactly what we're talking about here. Prime numbers are extremely important because they are the building blocks of all other numbers. Just like atoms make molecules, and molecules make matter, solids, liquids, gases, or plasma, so too do prime numbers make up all other numbers. So in many ways, prime numbers are sort of like atoms. Those little tiny subatomic particles that make up everything, that make up matter, solids, liquids, gases, and the 4th state of matter called plasma. Well, you can equate prime numbers to also being like atoms. Alright, so let's keep going. So we have to define prime and composite. Well, what is a prime number? Well, it's any number divisible only by 2 numbers, 1 and itself. So any number only divisible by 1 and itself, which we're going to see a few examples of in just a moment, which we also saw last class. And a composite number, it's quite an easy definition. If people know a prime number, not everyone knows what a composite number is. Basically, it's any number not prime. Alright, well that's easy to realize, because if it's not prime, then we call it a composite, because it is composed. Composed, you get it? Because it's any number that is composed of other factors besides 1 and itself. So, let's write all the factors of each number, and we're going to determine if it's prime or composite. Now, I'll do the first 2 with you, and then the rest are on you to do, okay? So, here we go. We have a 30, a 31, a 45, an 87, a 41, a 51, an 89, and a 121. All right, you're going to fill in the rest of them that I don't do. Let's start with number 30. The best way to determine if something is prime or composite is to actually ask yourself, are there 2 numbers that make 30 when you multiply them together? And I like to make a list from one end to the other, so to the far left to the far right, and fill everything else in between. So look at number 30. 30, as we saw earlier, is composite for many reasons, okay? We know it's divisible by 5, we know it's divisible by 2, but there's not just those numbers. So we know every list of factors, whether it's prime or composite, always begins with the number 1 and ends with whatever number you're talking about, in this case 30. Because 1 times 30 gives you 30. But what other 2 numbers multiply together to give you 30? Well, we know 2 does. So 2 times what gives me 30? Well, that would be 15. Notice how I wrote 2 on the far left because it's small, and 15 on the far right because it's kind of bigger. We're putting these in order by doing it this way as well. All right, are there other numbers that multiply together to get me 30? Yes, there are. There's 3 times what? 3 times 10. 3 on the left, 10 on the right. We're filling it in, and as you know, as you can see, we're getting closer and closer to the middle, which means we're closer and closer to the end of our list. All right, I think there are other numbers that multiply together to get me 30. 4, no. 5, yes. Okay, 5 times 6 are 2 other numbers that get me 30. Now, are there any more? 7, 8, 9, 10. Well, 10 we already have on there. And so we've completed our list. 1, 2, 3, 5, 6, 10, 15, and 30. And please note what we have done is we have kind of made little rainbows. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Everything has its own match. Now, clearly, it's not just the only numbers 1 and 30 that are factors of 30. So therefore, this number is officially a composite, which you can abbreviate COMP. What about the other number? What about 31? 31, let's see. Okay, we know 1 times 31 make up 31. Are there any other numbers that multiply together to get 31? I can't think of any either. And if we look back at our list that we made at the start of last class, and if you look at the poster in front of you, 31 clearly is a prime number. So the only 2 factors, of course, are 1 and 31. So we can get rid of that other comma. Okay? So because of that, we know it is officially a prime number. Boom. Now, we also have, as you can see, 45, 87, 41, 51, 89, 121. Some of those are prime. Some of those are composite. Be careful. Be sure to cross-reference your list with the poster in front of you. And if it is composite, make sure you're writing all the factors, every single one. It's easy to sometimes leave things out. Okay? It's sometimes easy to leave things out. Please sure you're not. So pause this video right now, and please write the factors and indicate prime or composite for 45, 87, 41, 51, 89, or 121. When you are done, please continue on. All right. So now that you've completed the factors, it's time to talk about prime factorization, which is a little different. Not that it's going to be a different technique, it's going to use sort of the same techniques, only the answer is going to be different. Remember I said earlier that prime numbers are the building blocks of all numbers, just like atoms are all the building blocks of all matter? Well, that means that every single number, no matter how big or how small, can be broken down into its constituent prime numbers, meaning every single number can be factored down into only prime numbers, and all those prime numbers multiplied together will give you the number that you started with. Prime factorization, as you can see, is writing a number as a product of its primes. Now don't forget the word product right here. Product means multiplication, so we're going to be creating something called factor trees, which help us to do this very technique. Here it is for 630, and we're going to do 630 twice to indicate to you that it doesn't matter in what path you take, everyone's going to end up with the same prime numbers in the end. So let's do 630. Now here's how it works. You take 630, you write it at top. I want you to write a little upside down V there and give me 2 numbers that multiply together to get me 630. All right, well, we know 315 times 2. Now you might be thinking, Mr. Reps, there's a lot more than just 315 times 2 that will give you 630. Yes, this is true, but you only need to take one path for now. Multiple paths exist to the right answer, which I'll show you in just a moment, but for now, let's just start with 315 times 2. Now, if it is prime, you circle it, and we know 2 is prime. But 315 is not prime. This we know. It's divisible by 5. So make another little upside down V. In other words, its roots. 63 times 5 makes 315. 5 is prime, but 63 is not. 63 is 9 times 7. But 7 is prime, but 9 is not. 9 is 3 times 3. Both of those 3's are prime. Okay, good. Now you've just made your factor tree, your prime factorization tree. Now you have to kind of finish it off by writing what those prime factors are. Now, listen carefully. You want to write your prime factors in order. Very, very important, from smallest to least. So we have 2, we have 2 3's, we have a 5, then we have a 7. Now remember, it's a product, so therefore we still need to indicate that we are multiplying all these numbers together. Now this is going to sound crazy, all these numbers 2, 3, 3, 5, and 7 are prime. Grab your calculator and put into your calculator 2 times 3 times 3 times 5 times 7. Do that now. Once you have done that, you'll notice that 2 times 3 times 3 times 5 times 7 gets you back to 630, what you originally started with. So we can see that 630 has been broken down to its atoms, aka its prime numbers. Now, one thing I want you guys to do is be able to write them in order, okay? Always write your prime factors in order. Don't write a 3, then a 5, then a 7, then a 2. No, no, no. Put them in order from least to greatest. It's going to help you immensely in the future. I can promise you that. Now, Mr. Ripes, you might be thinking, what else can we use to get to 630? Well, we know 630 is divisible by 5, so we could also use 5 times 126. And 5 is prime, so circle that. 126 is not. That's 3 times 42. 3 is prime. 42 is not. 42 we know is 6 times 7. 7's prime. 6 is not. 6 is 2 times 3. So we took a different path from 630 by beginning with 5 times 126. But did we still get the exact same prime numbers? Let's see, we got a 5 there, we got a 3 there, we've got a 7 there, we've got another 2 there, and oh my gosh, a 3. So as you can see, all the numbers still work, okay? All the numbers still work. So it doesn't matter what path you take. As long as you do your math correctly, everyone is going to get the same list of prime factors. A 2, a 3, a 3, a 5, and 7. And again, I can't stress this enough. Please, 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 please write them in order from least to greatest. That's going to help you immensely when we're talking about greatest common factor and least common multiple. All right, so get into the habit of doing that. Now, is that the only path to take to 630? No. What I want you to do is pause the video now and create another factor tree of 630. What other two numbers besides 315 and 2, 5 and 26 can you start with? Okay? There are others. Feel free to do that. What about 10 times 63? There's a hint right there. Break that down and see if you still get 2, 3, 3, 5, 7. And again, if you multiply all its prime numbers together, you get the original number that you started with. All right, now, you see below, we've got a 32, a 56, a 59. I want you to create the prime factorization tree of that. Actually, I'll do 32 with you. 32, as we know, multiple ways to take it, but let's say it's 4 times 8, both of which are not prime. But 4 is 2 and 2, and 8 is 4 times 2. 2 is prime, and 4 is, 4 is once again 2 times 2. Pardon me there. 2 times 2, all of which are prime. So therefore, the prime factorization of 32 is 2, 2, 2, 2, 2. 5 2s. 1, 2, 3, 4, 5. As you notice, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But don't forget, crazy important, you are multiplying them all together. So make sure you're putting in your multiplication symbols. And what is 2 times 2 times 2 times 2 times 2? 5 2s. You get 32. So you're going to now do 56, 59. 59 might be a little easy. That's a good thing. And also I want you to complete on the next page, 83, 101, and 175, 180, and 420. Create the prime factorization trees of those numbers now. I will pause you pause the video and complete those. And when you're done, please go on to the next page. All right, you've created your prime factorizations of various numbers. But what if we threw some variables in here? Here's an important word, one that you're going to hear very often. Monomial. A monomial is nothing more than a number and a variable or variables together. Get used to seeing this word. Monomial. Monomial. What if we were asked to factor monomials? The nice thing is all the work that we've been doing still carries over. Yes, we have a few exponents here, but it ain't that bad. Watch, I'm going to do 28xy cubed with you, and you're going to find out that, wow, that really didn't take too much work. I'm just doing what I've done in the past. Just focus on 28. Forget the x, forget the y cubed for the moment. We'll come back to that in a moment. 28, as we know, is 7 times 4. 7's prime, 4 is not. 4 is 2 times 2. 2 times 2 times 7. Ah, that's 28. Pretty cool. So to create the prime factorization of 28xy cubed, a monomial, we first start out, of course, with 2 times 7. But notice that the number is not just 28, it's 28xy cubed. And remember, whenever you have a number next to variables, it indicates multiplication. So 28xy cubed is 28 times x times y cubed, which we are going to explode out as times x times y cubed. Don't write y cubed. Y cubed is y times a third y. And guess what, folks? Now we're done. There it is. The prime factorization of 28xy cubed is 2 times 2 times 7 times x times y times y times y. 3 y's, 1 x, 2 2's, and a 7. Done. Congratulations. You just prime factorized your first monomial. Let's do another monomial, and the rest will be on you. 3x cubed y squared. 3. I like the number 3. Not really much to prime factorize there. That's 3 times 1, both of which are prime, because 3 itself is a prime number. This we know. So therefore, 3x cubed y squared, it's not going to be too much work. First of all, you don't have to write the number 1, okay? Just write 3 times x cubed is x times x times x. And y squared is y times y. OMG. We're done. That's it. That's all. Basically what you're doing is you're sticking a firecracker up into that monomial, lighting the fuse, waiting for a few seconds, and watching it explode out into its prime factorization. 3 times x times x times x times y times y. So think of it as unsimplifying. We're making it look longer. We're making it look more complicated. That's the idea, because that's what we need to do when we are going to do a process called finding the GCF and LCM, greatest common factor, lowest common multiple, of monomials, which is what we're going to be doing in the future. Please pause the video now and complete the prime factorization of 6ab, 15m cubed, and 36s to the fourth times t. And that's the work that we have to do. So pause the video now, please work on those 3, create the prime factorizations, and then of course, go to the next page to finish this off. We saw this earlier in last class. If you need reference in your notes because, well, we don't really always carry around a list of prime numbers in our pocket, maybe you do, and that's cool if you do. But if you don't, you got them right here. Here's a list of the first 100 primes, just like the poster in front of you has. And it wouldn't be enough if we just had that. Here's a list of the first 100 composites. But there are also numbers called twin prime numbers. Remember, there's many different types of numbers, just like there's many different types of sports. Please read this over. Check out what twin primes are. Oh, there's things called symmetric primes. And here's the description right here. Please read that over. And then this is by far my favorite. There are prime numbers called MERP. And I want to read this to you. An MERP is a prime number that remains a prime when its digits are reversed. So for example, 11. Reverse the digits 11, still prime. 13. Reverse the digits 13, you get 31. Both 13 and 31 are prime. 17 and 71. 79, 97. Those are called MERPs. Why are they called MERPs? Think about it. Look at this word MERP and think about what it's saying. Its digits are reversed. Well, look at the letters of MERP. Find out if you get it. I'll be asking about that next class. There's also things called relatively prime numbers. Oh my gosh, we've talked about those. Their greatest common factor is 1. We've talked about those. All right, here's the formal definition. Here's a few examples. And that's the type of prime numbers that we have. All right, so nice job, folks. Ideally, at this point in the video, you have completed the entire notes. Nice job, nice work. Please submit these notes into Canvas. There is an assignment there. Just submit it into Canvas like normal. I will look them over. You probably have a few more minutes in class now, which is a good thing. Please continue to work on the following. You can correct your quiz mistakes. Please work on the Khan Academy skills that I have recommended for you, the new ones. And if you haven't completed these class notes, feel free to go back and do that as well. So you should have plenty of time to finish those 3 tasks, okay? If not, it is officially homework. the biggest part, I want you to correct your quizzes. Now, you might notice you got your quizzes back. There was no grade on it. Mr. Ripes, what's up with that? But my friends, there will be a quiz grade on it after you make your corrections, because I will take those into consideration when determining your final grade. Feel free to email me. I look forward to seeing you. I'll be in school tomorrow, and of course I'll see you tomorrow. Take care.